All right. So page 53, there are types 1 to 3, so that we're focusing on type 1 today. Okay? Types 1 to 3 require you to create a table, and you have to produce, I'm going to use a different color for that, at least 3 points. I already mentioned that, to perform a regression. You need to come up with 3 points. Okay? And profit, revenue, it will have to do with money. Okay, folks? So if you see money, chances are we're going to be in this category right here. And keywords are profit, revenue, items sold. So if you see any of that, you're probably in this category right here. How will you approach this? These are the steps. You make a table with 3 entries like this. So you have the cost and price per item. I'll write that down, per item. Okay. Then the middle column is going to be number of items. So you'll have a question where, hey, you can buy, toilet paper for, $1 each. And how many do you sell at that point? And then the last one is going to be profit, which is the cost times the number of items. Okay? So this one right here, this one at the end, I want you to use a highlighter to say that this last one right here always goes into L2. Always L2, or our Y variable. Okay, that's very important to remember. Whether you use this into your L1 or this into your L1, that is going to be totally dependent on the question. Okay, are you comparing the price per item to the profit, or are we comparing the number of items to the profit? That's what you're going to have to figure out. Enter either cost or items into L1, profit into L2. There it is one more time. The profit goes into L2. What goes into L1 depends on the wording of the question. Okay, if it's relating cost and profit, then you put cost into L1, profit into L2. If it's comparing items, like the number of items you sold and the profit, then items goes into L1, but guess what? Profit goes into L2. There you have it, L2 again. Okay, pay attention to this one. This is where it's a little tricky. Mr. Erickson, there are 3 columns, but it's L1 and L2, right? Yes. Please don't put the first 2. A lot of students go L1, L2 like this, and then they get A equal to 0. You're going to get a linear function. That's wrong. So if you just remember to put this last one into L2, you're going to be fine. Perform the regression using quadreg. Make sure your resulting equation does not have A is equal to 0. This will be linear. Okay, I'll just highlight that one more time. And it says L1 and L2 are being used. Turn on plot 1, just like before. Use zoom 9, that's zoom stat, to see the graph. Adjust the window until you see the entire parabola in quadrant 1. So some of you are probably not going to need this, except for maybe this part right here. If it's a profit question, this is what you kind of need to set up. Okay. So, in general, it's very sluggish again, my screen. I don't like that. It's not. Generally, questions of this type will ask how the profit can be maximized. Okay, how the profit can be maximized. That is going to be the key focus for us. How can you get the most money out of this situation? Page 53. This means that you will need to find the vertex. Okay, you find the vertex. A break-even situation would happen at the x-intercepts. So, using the illustration above, let's say you put cost into L1 and that would be dollars, and you compare that to profit, because remember, profit is always going to be in your y axis. Then, at this point, if you find the vertex, it'll be the cost that will give you the max profit. So the question is going to ask you, hey, at what price do you need to sell your toilet paper at to make the most money as a company? I don't know why I'm using toilet paper, but just go with it. Okay. Or you could be on the other scenario where you have profit still on top, it's in dollars, and you're going to have, at the x-axis, you're going to have items sold. Toilet papers, rolls sold, right? So in this case, the vertex is still going to give you the max profit, but it's going to be items sold and the resulting maximum profit that would bring. So either way, whichever one you put into L1, okay, whether it's cost or items, you're still going to get the max profit out of both situations. Okay? I'm going to highlight that. I'm going to say green, green. You're still, the dollar amount that you get out of that is going to be the same. If let's say it's $100,000 that you make maximum, whether you do it this way or this way, you're still going to get $100,000 in both situations. Okay. I'm going to just mention the break even. It doesn't happen very often, but then at least you know, right? This point right here and this point right there is called the break even points. Go ahead. And think about it. How much profit do you make at this point? 0. Same here. So that would be the idea. And one more thing before we start actually solving this, okay? Let's make sure you write this down. You gotta have it right in your notes. I need you to understand this. Look at this graph right here. I'm going to use 2 different pencils. So as the cost of the toilet paper goes up, right, because the number would go up, so does your profit, right? So let's do them side by side. So you keep increasing the cost of the toilet paper until you get to the point where you get the maximum money as a company. But what starts happening if you start charging too much, like more than this point right here? Your profit actually starts going down. Why is that? Because you're going to sell less. You're going to sell less. So this is kind of, oh, what did I do here? So this is like the sweet spot right here. Like and this is what all companies are trying to find. Like, what's the sweet spot where we sell the most? Like Apple, when they release their new iPhone, what is it now, 16? It's crazy. And then they skip. Sometimes they skip, right? But they try to find, like, what price can we charge for this thing to get the maximum profit? And when they realize, oh, shoot, they're not selling a lot, they're probably somewhere out here maybe. So they're going to try to scale back their price per cell phone to get that sweet spot. If they sell it for too cheap, they're also not going to make that much profit. You know what I'm saying? So there's a bit of a supply and demand dynamic. That's what's happening there. So let's go to 54. 54 here. Let's do an example from scratch. I would argue this one isn't that difficult, honestly, because I set it up for you. The question kind of just tells you what to do. I'm not going to say it's easy, but if you practice, you'll be prepared. So let's go to 54 here. A movie theater charges $1.80 per ticket. Okay? At this price, it sells approximately 400 tickets per day. The manager has observed that for every 10-cent increase in ticket price, 40 fewer tickets are sold. So the manager has made that observation. They've kept track of their statistics. Okay? So you highlight those important things. So it's $1.80 per ticket. At that price, you're selling approximately 400 tickets per day. Okay, so there's the price per item and the number of items in this case, tickets, right? Then you observe, this is the dynamic that I want you to highlight with a different color. For every 10-cent increase, 40 fewer tickets are sold. That's how things are going to change here. Let me just... So, you decide what you want to do with the first two, but I can guarantee you we're going to put profit at the end, which will be cost times, in this case, tickets. That's how you would find out what the profit is. So I will make my first column here cost per ticket or price per ticket. I honestly don't care. Okay, price per ticket, cost per ticket. And then here you're going to say, well, number of tickets. And this could have been in reversed order. I don't care, right? You just have to make sure these are the two things that I need to come up with my profit. Now, let's fill in. You see how I have 3 rows here? Because how many points do we need? We need 3. So if the price is $1.80 per ticket, I sell 400 of those. My profit, therefore, is going to be 180 times 400. And I'll come up with that number shortly. Just leave it like that for now. So what's going to happen next? If I increase this price by 10 cents, what would it turn to? It would be 190, correct? I added 10 cents to it. What happens to the number of tickets? I actually reduce it. 40 fewer tickets are sold. So this would be 360. Right? At that price, I sell 40 fewer. So that would be 190 times 360, and we're going to get a profit there of some sort. One more time. If you add 10 cents again, this turns to be $2. This would reduce by 40 again. So 360 minus 40 is 320. So you're selling fewer tickets as you increase the price. That would give you $2 here times 320. And we're going to get a dollar amount there. You basically are very close to finding your 3 points. All right. Before I fill this, well, let's go ahead and fill that in. I'll show you the shortcut later on, but it's 180 times 400. So that's $720 made on that day. Then it's 190 times 360. That's 684. Then it's 2 times 320. That's 640. What did we just do, folks? We found 3 points that are on that parabola, but we don't know where they are, right? Like, not really. We just found 3 points. You will make sure you put this into your L2. That is Y. And which one of these are we going to put into our L1? And here's the kicker. You got to read. Determine the equation relating the ticket price. That will go into L1. And the profit, that goes into L2. So the wording of the question tells you what to do in terms of the L1. So ticket price is right here. This is our L1. That is our X. And this goes into L2. Let's go ahead and do that. Let me keep those points on there. Stat, edit, clear, clear. And just go ahead and type that in. Three points. Stat, calc, quadrag. I'm going to hit enter. I will just tell because next year it's not always going to be quadratic regression. It's going to be cubic regression, sinusoidal regression. There's going to be different regressions, so get used to writing this down. This is going to be negative 400 x squared plus 1120 x, and there's no, the c is 0, so that's good enough. Okay, so we graphed it. What ticket price would result in the maximum profit? So by the way, I have this graph here for a reason. You now know that this equation will have the price per ticket, that's a dollar amount. You can barely see it, but I'm writing down price, and this is profit in dollars. Okay. So usually this starts at 0, 0. We know that the y-intercept is 0. Y-intercept is 0, 0. So that's why we start there. And then the graph goes like this and hits the ground there. Let's make this appear on our window. I think that's important here. I hit graph and it's not a good window. It's actually pretty bad. Plot 1 is turned on. Notice my equation in y1 looks weird. That's okay. Leave it. That's what I want you to use. You copied it in there. So we're going to go zoom stat. I'm going to try that. And what do you notice? We know that our parabola is pointing down because it's a negative a, right? I'm looking right now at that right leg to the right of the vertex. That's what I'm looking at. So I need to go further that way. Press your window. I'm going to ask you to struggle a little bit with this. Try to find a window where this is in quadrant 1. You try that right now. I'll just pause in terms of finding the window because it's very important. So right now, I have a piece of paper here on the background. Right now, you should imagine, right? That's what you should be picturing. So if you wanna see more this way, you need to change your y min. I automatically, watch this. When it's a word problem, if this is positive, I'm immediately gonna change it to something negative. I don't know, -2, -5, something like that. And I'm gonna hit graph. And that ensures that the y-axis shows up. Okay? So now, right, if you picture this, you have the parabola continues, oh, there we go, up there. So I'm going to change my y max as well. So maybe don't change too many things at the same time. I'm going to change that to what, 1500? Let's try that. That's overkill. Just 1000 will do. Even that is a little overkill, but that's okay. Then I'm also going to change my y min. I'm going to change that to just under. So x min, y min, guaranteed something in the negatives. Okay? So that's much better. And now I'm going to change my window. I'm going to adjust the x max to 10. 5 will do, okay? You say 5, let's try that. 5 is probably better. Okay? So look at these 3 points. That's what you were zoomed in to. So maybe on your study sheet, I will do this. Not study sheet yet, just here. Okay? X min, -5, y min, -5. It's almost like a given because then you're seeing -5 here and -5 here, so you will surround your quadrant 1 that way. Okay. Okay, so the maximum profit will be at the vertex. Okay. What ticket price will result in the maximum profit, and what is the maximum profit? Let's find the vertex. Second trace max. Okay, so we're going to find that vertex where the maximum profit is going to be found. Second trace max, go to the left, go to the right, and the max is, I'm going to write down the coordinate, 1.40, 784. That is the coordinate of the vertex. So this represents the ticket price. This is the profit. Okay? A ticket price of $1.40 will result in a maximum profit of 784. Okay? So you need to understand that this is the ticket price and this is the profit there. Okay. How many tickets are expected to be sold at this price? This is what I want you to think of. Profit, yeah, some of you just did some math and you figured it out. But the profit is, remember, it was the cost per ticket times the tickets. Correct? And so we have the profit, which is 784. The cost per ticket is $1.40. And this is X right now, the number of tickets. So what we're going to do is we're going to divide both sides by $1.40. Cancels out. So, right, 784, it's a different calculator, sorry. So it's 560, round if you have to, but X is equal to 560 tickets. Is the bell about to go? Yes, about to go, but not yet, not yet. Let's finish this one. What ticket price or prices would give or yield a profit of $4.50? This is what it's asking, folks. What ticket price would give you a profit of $4.50? What would you do to find that? If you, Y2 is equal to 450, right? Y2 is equal to 450. Second, trace 5. But watch out, what's going to happen here? Let's graph the 450. It happens twice. It happens here and here. Okay? So we're going to find both of those. I'll just give you those. X1 is 049. A price of 49 cents a ticket or 231 will yield, that's a weird word, yield means will give a profit of 450. Before you pack, okay, I need you to practice this and I'll post the keys. I think it goes 55 to, I'm just going to go 56, I think. Hold on. 55, no, sorry, 56 to 57. That's what I'm going to do. Okay? Page 56 to 57. I'm not asking for a whole lot. 2 questions. Okay? The graphing and all of that I didn't do on this one, but you should be able to do the graphing just like before. Okay? All right, guys. Thank you.